Welcome to Astronomy Daily, your daily dose of the latest cosmic happenings. I'm Anna, and I'm thrilled to guide you through today's fascinating discoveries. We've got an exciting lineup for you. First, we'll dive into the highly anticipated next flight of SpaceX's Starship, the colossal rocket making headlines. Then, we'll explore the astonishing secrets unveiled about a powerful, rapidly spinning neutron star, thanks to new X-ray observations. Get ready for a cosmic first as we hear about astronomers witnessing a solar system being born right before their eyes. And finally, we'll talk about the multi-million-dollar auction of the largest Mars meteorite ever found on Earth that I reported on yesterday. We have the auction results. Stay with us for all these stories and more. Let's kick things off with some exciting news from SpaceX, as Elon Musk has announced that the next Starship flight, the 10th test flight of this colossal rocket, is expected to launch in about 3 weeks. If all goes according to plan, this will be the 4th launch for Starship this year. And it's a big deal because Starship is designed to be the biggest and most powerful rocket ever built, with both its super heavy booster and ship upper stage intended for full and rapid reusability. Now, getting to Flight 10 has been a bit of a bumpy ride. The ship upper stage that was originally slated for this mission actually exploded on a test stand at SpaceX's Starbase site in South Texas back in June during preparations for a common pre-launch engine trial. SpaceX quickly pinpointed the likely cause, a failure of a pressurized nitrogen tank in the ship's nose cone area. The team is now working diligently to get a different ship vehicle ready for this upcoming Flight 10. It's no secret that the ship upper stage has faced some challenges in recent flights. SpaceX unfortunately lost the ship vehicle on Flights 7, 8, and 9, which launched in January, March, and May of this year, respectively. For example, on Flight 8, which launched back in March, the 171-foot-tall ship upper stage was intended to deploy dummy Starlink satellites and then perform a controlled splashdown in the Indian Ocean. However, several of ship's 6 Raptor engines conked out towards the end of its ascent burn, causing the vehicle to tumble, and SpaceX lost contact about 9 minutes into the flight. It presumably detonated high in the sky shortly after. This mirrored what happened on Flight 7, where the ship was also lost at a similar point in the mission. The anomaly on Flight 7 was later traced to a harmonic response that was several times stronger in flight than observed during testing, leading to increased stress on propulsion system hardware, propellant leaks, and sustained fires. For Flight 8, SpaceX had already taken steps to minimize the chances of recurrence, including a longer static fire test and hardware changes. In contrast to the ship, the Super Heavy booster has shown a more consistent performance. On Flight 7 and Flight 8, the booster successfully returned to Starbase and was spectacularly caught by the launch tower's chopstick arms. This was a jaw-dropping demonstration of a technique that SpaceX is refining. Flight 9 even featured the first-ever reuse of a Super Heavy booster, putting the Flight 7 booster back into action. Though on Flight 9, SpaceX didn't attempt to catch the booster again. It broke apart over the Gulf of Mexico shortly after initiating a landing burn. Over the long haul, SpaceX plans to employ this chopstick recovery strategy for both Super Heavy and ship. This approach is key to making the reuse of each stage more efficient, with the ambitious goal of flying Starship multiple times per day. The ultimate vision, as articulated by Elon Musk, is that Starship's combination of immense power and full reusability will make Mars settlement economically feasible. The company has been steadily increasing its flight cadence, having flown in a fully stacked configuration for the first time in April of 2023, followed by another 2 flights in 2024, and already 4 so far this year. We should expect another significant boost in cadence, as SpaceX has already requested approval for an astounding 25 Starship launches from Starbase this year. So some quick turnarounds may be required if they wish to still reach that goal. And as of next year, SpaceX are looking to complete some 120 launches a year. It's certainly a dynamic time in the world of space exploration, and we'll keep a close eye on Starship's next giant leap. Next up, we're diving into a groundbreaking discovery about a powerful, rapidly spinning neutron star known as PSR J1023 plus 0038, or J1023 for short. Astronomers have uncovered a major secret about this pulsar, revealing that the radiation it emits is primarily driven by the impact of its intense particle winds, rather than the material it strips away from its companion star. This is a significant finding that sheds new light on these fascinating cosmic objects. J1023 is truly a marvel. Located about 4,500 light-years from Earth, it's part of a binary system where a dead star or neutron star spins an astounding 600 times per second while circling a low-mass companion star that it feeds upon. Its rapid rotation categorizes it as a millisecond pulsar. What makes J1023 even more special is its status as a transitional millisecond pulsar, a rare subclass because it clearly shifts between an active state where it's accreting material and blasting out radiation, and a more dormant state where it behaves like a standard pulsar emitting radio waves. This makes J1023 an invaluable cosmic laboratory for scientists. Traditionally, when a neutron star feeds on its companion, the stripped matter forms an accretion disk that swirls around the dead star, gradually feeding it while emitting powerful radiation across the electromagnetic spectrum. However, this new research tells a different story for J1023. The team used an impressive array of instruments for this study: NASA's Imaging X-ray Polarimetry Explorer, known as IXP, along with the European Southern Observatory's Very Large Telescope in Chile and the Carl G. Jansky Very Large Array in New Mexico. This was the first survey of a binary X-ray source observed across the X-ray, optical, and radio bands of the electromagnetic spectrum, allowing them to precisely determine the polarization of the radiation coming from this pulsar. What they found was particularly exciting. IXPE observed that a remarkable 12% of the X-rays from J1023 were polarized, which is the highest level of polarization ever seen from such a binary star system. While the radio waves and optical light emissions showed lower polarizations of 2% and 1% respectively, the optical polarization was oriented in the same direction as the X-ray polarization. This alignment strongly suggests a common mechanism behind both phenomena. These findings confirm an earlier theory. The observed polarized emissions from binary systems like J1023 are generated when the pulsar's powerful winds, streams of high-energy charged particles flowing from the dead star, strike the matter in the surrounding accretion disks. This observation, though extremely challenging due to the low intensity of the X-ray flux, was made possible by IXPE's exceptional sensitivity. This research could finally help scientists unlock the secrets of what truly powers pulsars, offering us a clearer picture of these incredible objects. Moving from distant pulsars, let's turn our attention to something incredibly exciting that brings us closer to understanding our own origins. For the first time ever, scientists have witnessed the very earliest stages of planet formation around a baby star, roughly 1,300 light-years away. This groundbreaking discovery means astronomers actually watched hot minerals crystallize into solid particles, effectively catching a planetary system at the precise moment when planets begin to take shape. It's like having a cosmic time machine, offering an unprecedented glimpse into the birth of our own solar system. This breakthrough came from studying a young star named HOPS 315, which is encircled by a swirling disk of gas and dust called a protoplanetary disk. Using the incredible power of the James Webb Space Telescope and the Atacama Large Millimeter Array, or ALMA, astronomers detected silicon monoxide, or SiO, as it transitioned from gas into solid crystalline minerals. This is considered the absolutely crucial first step in planet formation. Melissa McClure, the lead author from Leiden University, highlighted the significance, stating that for the first time, they've identified the earliest moment when planet formation is initiated around a star other than our sun. This finding provides an unparalleled window into how rocky planets like Earth actually come into existence. It's fascinating to consider that in our own solar system, similar crystalline minerals are found trapped in ancient meteorites, primordial rocks that scientists use to date the beginning of our solar system. These meteorites contain the very same silicon monoxide compounds now being observed around HOPS 315, albeit in their fully solidified state. Merrill Van Hoff from Purdue University eloquently described their discovery as a picture of the baby solar system, noting that we are truly seeing a system that looks like what our solar system looked like when it was just beginning to form. The research team pinpointed that this mineral formation is occurring in a region equivalent to the location of our own asteroid belt around the sun. This isn't a coincidence. It's exactly where astronomers would expect to find the building blocks of rocky planets. The process itself is quite elegant. Close to young stars, the intense heat keeps silicon monoxide in a gaseous state. But as temperatures drop with increasing distance from the star, this gas starts to condense into solid crystals. These tiny particles then begin to stick together, gradually growing larger until they form kilometer-sized planetesimals, which are essentially the seeds that will eventually become full-fledged planets. Edwin Bergen, a co-author from the University of Michigan, emphasized that this process has never been seen before in a protoplanetary disk or anywhere else outside of our solar system. The detection required the combined might of two of astronomy's most powerful tools. The James Webb Space Telescope initially identified the chemical signatures of these crystalline minerals, and then ALMA precisely pinpointed their exact location within the protoplanetary disk, revealing that they were forming in a narrow ring around the star. The observations not only showed gaseous silicon monoxide actively condensing into solid particles, but also revealed carbon monoxide streaming away from the star in a butterfly-shaped wind, while silicon monoxide jets beamed outward in narrow streams. This discovery transforms HOPS 315 into a natural laboratory for studying planetary formation. Logan Francis, a postdoctoral researcher at Leiden University, pointed out that they are literally seeing these minerals at the same location in this extrasolar system as where we find them in asteroids in our own solar system. The findings strongly suggest that planet formation follows universal patterns across the galaxy. The same physical processes that created Earth and other rocky planets in our solar system are actively occurring around distant stars, providing astronomers with living examples of planetary birth. This opens up exciting new possibilities for understanding how common Earth-like planets might be throughout the universe, all while offering direct observational evidence of the processes that shaped our cosmic neighborhood 4.6 billion years ago. From the birth of solar systems to more tangible relics, let's talk about something incredibly rare that just changed hands for a hefty sum. As I reported yesterday, the largest Mars meteorite ever found on Earth was auctioned off at Sotheby's in New York City. This jagged 54-pound chunk of the red planet, formerly known as NWA 16788, sold for an astonishing $4.3 million. Interestingly, the bidding war wasn't quite as fervent as some expected, even though its starting price was already set at $2 million. Still, the final sale price surpassed the initial maximum estimate of $4 million, with extra fees pushing the total lot price to around $5.3 million. Cassandra Hatton, the vice chairman of science and natural history at Sotheby's, highlighted that NWA 16788 isn't just notable for its size, being about 70% larger than the next biggest Mars meteorite on Earth, but also for its appearance. She noted that it literally looks just like the surface of the red planet, distinguishing it from smaller, less striking Martian meteorites that often sell for tens of thousands. The identity of the new owner of this unique piece of Mars remains private, as buyers often choose to stay anonymous for various reasons, including safety or a desire to be an anonymous donor to a museum. This Mars rock was just one of many rare items sold at the auction, which also included a juvenile Ceratosaurus skeleton for $26 million and a Tyrannosaurus rex foot for $1.4 million. The auctioning of scientific objects often sparks debate. While some argue such items should be freely donated to scientific laboratories or public spaces, Hatton suggests that attaching monetary value can incentivize collectors to properly care for them, perhaps even better than underfunded museums. She also points out that many collectors do end up donating their purchases or allowing them to be displayed, sometimes even providing additional funds for the institution to care for the objects or support postdoctoral researchers. To verify its authenticity, a small piece of NWA 16788 was indeed broken off and sent to a lab for analysis, with the findings published in the Meteoritical Bulletin, making data available for scientists. And that brings us to the end of another fascinating episode of Astronomy Daily. Thank you for tuning in. Don't forget to visit our website, astronomydaily.io, where you can catch up on all the latest space and astronomy news with our constantly updating newsfeed. And if you're a completionist, you can listen to all our back episodes. Let me know if you do, and I'll give you a shout out here on the show. You can also subscribe to Astronomy Daily on Apple Podcasts, Spotify, YouTube, or wherever you get your podcasts. We'll be back tomorrow with more cosmic updates. Until then, this is Anna signing off and reminding you to keep looking up.